Welcome. If you're getting ready for a machine learning interview, you are in exactly the right place. We're going to do a quick but crucial stats review, breaking down the fundamentals you absolutely need to know for your technical exams.
So here's our game plan. We're going to start with a really simple, real-world problem, expose a hidden issue within it, find the right tools to get a clearer picture, and then, this is the important part, we'll connect that whole lesson to a core concept in machine learning.
Okay, so picture this. You're choosing a university. One of the first stats you're probably going to look for is the average salary package for graduates, right? It seems like a simple, straightforward number, but you'll see how it can be pretty misleading.
All right, so you get this list of salaries from recent grads. Your job is to figure out what you might realistically earn. What's the go-to knee-jerk calculation you'd make to get a single number that represents this whole list?
And here is that list. It's data from just 7 students. And you can see right away the numbers are kind of all over the place. We have salaries starting at 2 lakh, and then one person got a whopping 32 lakh package. That's a pretty wide spread.
For almost everybody, the first instinct is to calculate the mean, the good old average. You just add up all the salaries, divide by the number of students, and bam, you have your number. It's the first thing we all learn to do in stats.
And if you do the math, the mean for this data comes out to 9 lakh. Now on the surface, that sounds pretty great, doesn't it? A 9 lakh average? That's a strong selling point. But just look back at the actual data. Does 9 lakh really feel like it represents the typical student on that list?
And that question brings us to our next big idea. Let's dig into how just one single data point can completely warp our perception of the truth. This is a critical lesson, both in statistics and in machine learning.
In statistics, we have a name for a number that's way different from the rest of the group. It's called an outlier. And looking at our data, that 32 lakh salary, that is a classic textbook example of an outlier. It's the exception, not the rule.
And this is the most important thing to remember about the mean. It is highly sensitive to outliers. Think of that 32 lakh salary as having a massive gravitational pull. It drags the entire average upwards, making the situation look much rosier than it is for most people.
Okay, so if the mean is giving us a distorted view, how do we get a more honest answer? How do we find that typical student salary? Well, this is where we bring in the mean's 2 best friends, the median and the mode. And this slide says it all. Look at the difference. The median is simply the middle value when you sort all the numbers in order. For our data, that's 5 lakh. And notice, the crazy 32 lakh outlier has 0 effect on it. Now that number, 5 lakh, feels a lot closer to the real experience of most students, doesn't it?
And then you've got the mode. The mode is just the value that appears most often. Now in our little salary data set, no number repeats, so there technically isn't a mode. But imagine you're a company like Netflix. The mode would tell you the single most watched movie. It's all about finding the most common outcome.
So finding the center of the data is a great first step, but it's only half the story. We also need to ask, is the data all tightly clustered together, or is it spread out all over the place like our salary example? The simplest, quickest way to measure that spread is the range. You just take the highest value, 32, and subtract the lowest value, 2. You get 30. A range of 30 lakh is huge. It immediately tells you there is a massive amount of variation in the outcomes for these students. For a more powerful measure, though, we use standard deviation. You can think of it as the average distance of any given data point from the mean. And you can see here our salary data has a really high standard deviation of 9.6. That just confirms what we already suspected. The data is super spread out. A more consistent data set where salaries were all close together would have a much lower value, something like 2.0. So, mean, median, mode, standard deviation. Why does any of this actually matter for your machine learning interview? Well, let's connect these exact concepts to a very famous ML algorithm, the decision tree, and its even more powerful cousin, the random forest.
So a single decision tree can be a lot like our mean. It can become overly influenced by specific, weird data points, or outliers, in the data it's trained on. This leads to a classic and very common problem called overfitting.
Overfitting is when your model performs perfectly on the training data. It's like it memorized the answers to the test. But then, when you show it new data from the real world, data it's never seen before, its performance just completely tanks. It fails to generalize what it's learned.
And this is where the random forest comes in to save the day. It's a brilliant solution. Instead of relying on one fragile decision tree, you build a whole forest of them. Each tree is trained on a different random sample of the data. Then, you just aggregate all their predictions. It's the exact same principle as using the median instead of the mean. It's more robust, it isn't swayed by one single outlier, and it gives a much more reliable result.
Okay, we've gone through a lot, so let's boil it all down into a simple cheat sheet. These are the absolute key takeaways you need to have in your back pocket for your exam.
So, here it is. The mean is the average, but always be careful. It gets pulled around by outliers. The median is the middle value. It's your go-to when you suspect you have outliers. Outliers are those extreme values that can wreck your analysis, so always hunt for them. Range and standard deviation tell you how spread out everything is. And finally, a random forest is like taking the median of a bunch of models. It's more robust to variation and gives you a better answer. If you get these concepts, you're in great shape.
So that wraps up our quick review. The next time you see a headline with the word average in it, you'll know to dig a little deeper and ask what that number might be hiding. And the next time you're building a model, you'll remember why a whole forest is often stronger than a single tree. Thanks for watching.